Welcome to Lesson 1, Geometry Basics. Our purpose of our lesson today at some specific vocabulary. Now obviously there's a lot of vocabulary we're going to be kind of defining today. If you can see, we're going to be identifying a point, line, plane, collinear lines, collinear points, line segment, ray, opposite rays, intersect, and intersection. And I know that's quite a few new terms, especially for the first lesson. You'll find that geometry is full of vocabulary. It's basically like learning another language. Don't worry about writing these down yet. We'll get to those in just a minute. But at least I wanted to just show you an outline of what we're going to be doing today. Start with a point first. A point, obviously pretty self-explanatory as to what that would look like. There's our point. So with a point, it's technically defined as having no dimension, and it's just represented with a single dot. Line's a little bit different. This is one-dimensional. That's an S right there. So one-dimensional. And as far as this line goes, it's going to extend without end in both directions. Okay, and there's our typical line. Okay, but again, it is one-dimensional, just extends for forever in both directions. We also are going to put two little arrowheads on the end, which indicate that it's a line, not a line segment or ray, which we'll get to in a minute. Plane goes. Planes, especially in our textbook, are going to look slightly different. Here's an example of a plane out of our textbook. Okay, this area in here. A plane is two-dimensional, so I'm going to go ahead and put that in here. It's two-dimensional, 2D. Okay, and this can really be about anything. For example, the best way to think of this is maybe like a side of a box. That side is a plane. Okay, so this, let's just say this front area here, that's a plane. So the big difference between lines and planes, with a line, we can create a line through any 2 points. Okay, that's all you need, just 2 points. Think about when you were a kid and you did connect the dots. You don't do connect the dot, right? You need 2 points to connect the dots. As far as a plane goes, we need an additional one. So to create a plane, we need at least 3. Okay? And again, it's kind of similar to that picture I have up there, like a parallelogram. That's our plane. Notice we can name the plane itself with that capital letter here, and there's 3 points within. Now, just because there are 3 points there doesn't mean there's only 3 points. We can have an infinite number of points on a line, infinite number of points on a plane, but there's the requirements at least to create those. Now into some collinear points. So collinear points, if you break down this word, the front part is just co. The last part, I'm sure you can see, linear, line, line points. So in other words, these are basically going to be lines that share the same line. Okay? So I'll go ahead and put the picture of these down first, and then we'll go ahead and define it. My points might not be exactly on there. Not bad. Whoop, that was a little crooked. That's okay. So these 3 points are an example of collinear points. And again, I'll go ahead and write that in. Points that lie on the same line. Okay. Planar goes. Coplanar is very similar. Coplanar, we have the co in front, so they're going to be sharing. If you think about co-workers have something in common. They share something. They share the place where they work. Co means together. Coplanar lines and coplanar points all happen within a plane. And this can be, again, like that shoebox I had a little earlier. I'll just draw a quick representation again of what our textbook has. as planes. So an example of two coplanar lines are line L and line M. Okay, so these are lines in the same plane. It's a little bit easier to see when we have a box example or a cube, which we'll do in a second, but those are lines in the same plane. Coplanar points. Okay, these are points, and I'll go ahead and just erase this real fast. If you need to rewind to write that down, that's fine. But I'll just put this one back up here. Coplanar points are points D, E, and F. Those are points that lie in the same plane. Okay. So there's a real quick definition of those. So we're going to try an example. If you'd like to pause the video now and try this example on your own and see if you're correct, that is fine. Otherwise, I'll just do a variation of some of these. There are multiple answers. First is A, okay? And we're going to look at 3 points that are collinear, any 3 points that are on the same line. So we can see for this one, actually there's only one answer. And I know we haven't talked about intersections yet, but we can see point D, point C, and where they meet at point A, right in the middle, those 3 points are collinear. Okay, those are the only options that are available for that question. For question B, 3 points that are coplanar, really anything but E. E is kind of outside. It's kind of hard to see what this is actually representing if you're struggling picturing what this looks like. I can show you a physical example in class tomorrow. But really any combination of points A, point B, D, and C. Obviously they only asked for 3, but as long as you have any of those except E, you're fine. 4 points that are not coplanar. Now obviously there are 4 that are. So again, you can put 4 of those. So let's just say I said A, B, D, and E. Even though that these 3 are, this set means that they are not coplanar because E is not in the same plane as A, B, and D. So that is a good example for part C. Okay. Again, if you want to pause the video now and try this example on your own, please feel free to do so. First part, name 3 points in the diagram that are not collinear. So now we're looking at this prism, this rectangular prism, and we have a couple collinear points, but really as long as you name several points that are not in the same plane, so for example this plane at the top, this plane at the bottom, although they are parallel planes, they are not collinear. So for example, we could just say point A, point G, point D, not even close to being on the same line. If you were to try to connect those, A, G, D obviously is not even going to come close to making a line. It looks pretty ugly. In fact, it's ugly enough that I want to erase it, so I'm going to go ahead and delete that. Okay, let's go ahead and go to the next one. Name the point in the diagram that is coplanar with A, D, and E. So again, that shares the same plane. So we're looking at this front plane, A, D, and E. It contains those couple points. That point should be here at H. A, D, and E, and point H is shared with those. Okay. We're just about done. We're going to go ahead and look at a line. Again, we did discuss a line already, so I'm not going to define that again. Again, it's defined by having 2 ends extended out and forever in both directions. For a line segment is a little bit different in the fact that it has 2 endpoints, and this can look a variety of different ways. Number 1, it can just look like this, and I know it might be hard to see some endpoints there, so I'm going to add some on. No, that's not the best. Dots right in center, but you get the idea. There's endpoints there. This can also be on a line as well. So for example, if I put in another line and I put in two endpoints on that line. This piece here, oops, not that one. It's okay, kind of ignore that one for now. This piece here is technically a line segment. So I can say this segment AB here, I can measure. I can't measure the distance of this line. So I could technically call this segment AB. If I don't want those endpoints included, then this is a line AB. So it's slightly different. Line segment. Segments indicate a start and a stop with our endpoints. A line has 0 endpoints unless we, again, want to measure the distance between. Array, slightly different. Let's see. So array is just a mixture of the two. It does have one arrow, but it also has an endpoint at the end. If we were to name this array, let's say we have the endpoint is at C, and we have another point here at D, we would just call this ray CD. That symbol indicates we're talking about ray CD. I was going to talk a little bit about opposite rays, but I believe I'll stop. I'll save this piece in addition to intersections for another time. Be ready to discuss some of this tomorrow in class and answer some questions. I'll probably have you working on some problems in addition to discussing as well. Please fill out your WSQ sheet right now as well and be ready to turn that in tomorrow. Thank you and have a good day.